Okay, guys, today we are going to start chapter 3. In chapter 1, we learned about collecting data, different types of variables, different types of measurements, things like that. In chapter 2, we started organizing data, and we did some graphical representing of data. Now, in chapter 3, we're going to start actually analyzing that data piece. So let's start off with what we're going to do is we are going to find the mean and modal class for grouped data. I know you've found the mean and mode before, but we're going to find it for grouped data. I'm pulling this information. I will write it on my screen, but if you need to refer back at all, it is on page 124, number 18 in your book. But I'm going to go ahead and just write the classes up here. I jotted them down on mine, so go ahead. And as always, guys, I did give you a handout, but if you prefer notes in your notebook, that is cool as well. I don't grade your notes. They are for you. 64 and then 64. Whoops, 65, jeepers. And 75. There we go. And our frequencies are 2, 8, 15, 7, 10, and 3. So that is the grouped data we're going to use. On your chapter 2 test, you guys had to create a group frequency distribution, so this should look familiar to have classes and our frequencies there. Now, if we want to be able to find the mean and modal class, if we're going to be able to find the mean for grouped data, what we need to do is we need to find our midpoints. So our midpoints, we should be familiar with that, again, from chapter 2. So our midpoints, you can add your class limits together and divide by 2 is one method. So if you need that refresher, add your class limits together and divide by 2. So we'll get 15 there. If you need to keep adding and dividing by 2, you can. Otherwise, our pattern, we're going up by 11 each time. We're going up by 11 each time, so our midpoints will also go up by 11 each time. Just remember that little shortcut. So we should have 26, 37, 48, 59, and then we land right on 70. So you will be given, or maybe you have to set up your classes. You'll have your frequencies. We know how to find midpoints. So far, nothing new for us. Then the last piece we need to do before we take a look at our formula is we need to do frequency times midpoint. If you've noticed, I've started throwing in some variables to represent those various things that we found before. So frequency, lowercase f. Midpoint is a capital X with a little m subscript. So frequency times midpoint, so for that first class, it just looks like this, 2 times 15. How many of those you want to write out is up to you. How many you want to actually show the multiplication, again, that's up to you. They're your notes. I would at least write down a couple for myself so I know, well, where did the 30 come from again? Where did the 208 come from again? I would at least write down the first couple where you did the multiplying. And remember, we've talked, guys, if you have not found your calculators yet, I would get working on that. Or if you borrowed a calculator from somebody last year, see if you can borrow that one again this year. So we just take each frequency times each midpoint. That's all we're looking at doing so far. Now in this unit, we're going to start seeing a lot of formulas. So we're going to be coming across some different variables and things. So the little formula for finding the mean for our group data is down at the bottom. I want to break it down and label those pieces for you, what each thing means. So we have an X with a line over the top of it. that is actually read as X bar. That is actually read as X bar. And what that represents, it is our sample mean. So we're going to find the mean. It's represented with X with a line over it, and it's actually read as X bar. It's actually read as X bar. The next piece, and again, you may or may not be familiar with, kind of depends your math background. Maybe you're in calculus right now and you're used to seeing those. Maybe you've taken pre-calc and you've seen those before. This is a capital sigma. And when you see a capital sigma, what that means is sum. It means sum. And if you don't remember what sum means, it means you're going to add everything together. That's a capital sigma. It looks kind of like a goofy capital E. Then we have our little, our little f. We know our little f is frequency, and the x with the subscript m is midpoint. The lowercase n on the bottom, that is our total number of data values. Total number of data values. It's also, the more technical name for it is the sum, of the frequencies. That's the more technical name for it. Sum of the frequencies. But it's the total number of data values that we have in our sample. So what we have done, we need, the top of our formula says we're going to take frequency times midpoint, and that capital sigma says we need to add them all together. So this top piece is going to be right up here. We're going to have the sum of f times x sub m. So all we have to do is add that final row together. So we see the symbols, frequency times our midpoint, and that's what our third column is. F times x sub m is frequency times midpoint. That's what that third column is. That capital sigma is our sum. It says, hey, you have to add all those things together. You have to add all those things together. And it's going to be 1,929. So the capital sigma says whatever comes after it, we have to add all those together. So that's our numerator. And then the denominator piece, that little n, and I'm going to run out of space there. Let me grab a different color here, stand out a little more. The n is just the sum of our frequencies, or our total number of data values. Add all our frequencies together, and that total is 45. And I know you might be thinking, Miss Callie, let me add those up, let me add them up. I'm going to do the busy work ahead of time for you guys, okay? I'm going to work under the assumption we can all add those values together. So then we do our division. We do our division, and we come up with 42.86, and the 6 repeats. If you have a terminating or a repeating decimal that works out so nicely like that, don't round it. Don't make that 42.9. We don't need to round those things. It's a nice repeating decimal. Leave it exact when you can. Leave things exact when you can. Okay? So what do we think? That is the mean for grouped data. I know we can look at that formula. It's like, holy cow, Miss Gal, I've never seen anything like that. There's some crazy symbols there. But once we break them down, though, the formula itself isn't super hard to use. All we're doing is multiplying our frequency and our midpoint for each class, and we're adding them all up. That's all the top is. I know it looks a little different than probably any formulas we've ever seen for most of us, but that's okay. We're just going to keep breaking down what those symbols mean. The last piece on this is your modal class. This is one of the easiest things we will find. All the modal class is, guys, is just the class with the highest, largest, biggest, whatever word you want to use, frequency. There's no formula. There's no extra work. All you literally have to do is look at your classes and see which one has the highest frequency. And the winner for us, the highest frequency, is 15. So 32 to 42, this would be our modal class. So if you were asked for the modal class, you would just tell me 32 to 42. You don't have to try to label it any other way. That's it. That's it. Questions for me on that first slide, if you will, or that top piece for you guys? All right, the next thing we want to look at then, and this is just something that I know you guys have never seen before. It's called the mid-range, and the mid-range is symbolized capital M, capital R. It's the sum of the highest and lowest values divided by 2. Now we're talking about this for the whole data set. This would be for your whole data set, so not just a class. If we're talking about a class, it's a midpoint. If you're talking about your entire data set, that's your mid-range. So that is how you find it. So for me, that would be an important thing to write down on my sheet. Sum of the highest and lowest values divided by 2. This next bullet point, I probably wouldn't waste my pencil lead on it. Easy to compute. Well, hopefully that's obvious because all we're doing is adding 2 values together and dividing by 2. So this isn't something, it would be an advantage, but it's not something I would bother writing down. It doesn't really stand out to me. It does give us that midpoint. If you're talking about a class, it will be titled midpoint. But when you're talking about the entire data set, it's referred to as your mid-range. So I wanted to throw that in there, that it gives you the midpoint, because we just computed midpoints, and that's exactly what we did. We added the highest and lowest class limits. We divided by 2. The downfall of the mid-range is if you have an extremely high or an extremely low value, those are referred to as outliers. We'll talk about them a little more later in the chapter. If you have an extremely high or extremely low value, that can make your mid-range a lot higher or a lot lower than what it should be. And we will talk about outliers later in this chapter, not today. So again, the mid-range is something that I know you guys have never seen before, but we've computed something similar in our midpoint. The last piece that I want to specifically go through with you today is something called the weighted mean. It's the only other thing from this section that I know many of you have never had any experience with before. So what you have is, to get your weighted mean, some of you I know have heard of weighted GPAs, and that's one of the first things that we're going to look at. You already have this on your sheet, the weighted mean. Multiply each value by whatever its weight is, and then you divide by the sum. Then you divide the sum of the products by the weight of your means. So that formula is on your sheet. We see the X bar again. Remember, the X bar is our mean. We need to get used to that symbol. We're going to find a lot of means. X bar is our mean. The W's with the little subscripts, those are our weights. And then the actual data values themselves are just represented by the X's. We see the capital sigmas again, meaning we need to add all those things together. And you can see it broken down in the actual formula when it's expanded out. So remember that capital sigma Just means we need to add all those different values together. Okay? So let's try this out. And I know a lot of you have probably heard of a weighted GPA. It does occur in college because in college, some of your courses are worth more credits than others. And that's where a weighted GPA comes in. Some classes are worth more credits than others. In high school, all your classes are just worth 1 credit each. So they all weight the same in your GPA. So what we need to do is we have our credits and we have our grade. Now, if we want to use our formula, I can't put an A in for my X values. So an A is worth a 4.0. A B minus is 2.7 towards a GPA. A C plus is 2.3. A B is a 3.0. And then again, we have another A is 4.0. And this looks like my first semester of college, my freshman year. All right, so let's break down what that formula means. In the numerator, we need to take each weight times its corresponding value. So in this case, how much weight a grade carries is associated with how many credits it's worth. So the more credits my class is worth, the more weight that class carries towards my GPA. So something worth 4 credits carries more weight than something with 3 credits. So for my first class, we have our calc class. We have a weight of 4. And then our plain old value is 4.0. I can't put an A in there because I can't multiply 4 times A. We're not trying to solve anything here. We're trying to actually figure out what that weighted mean is. Then our next course, Developmental Psychology. It carries a weight of 3 credits, and then it has a value of 2.7. Again, the more credits it is worth, the more weight it carries towards your GPA. Then we have American History is 3 credits again, 2.3. Principles of Public Speaking is another 3 credits, and it's 3.0. And then Physics for Engineers carries a weight of 4 credits, and it's a 4.0. Now, I usually get the question, Miss Guy, do we have to put like the 4.0 part when we do it in the calculator? You don't have to. I'm putting it up here, though, so you can associate the difference between how many credits and then that actual grade piece. So I wanted to make sure I put the 4.0 so you could distinguish between the weight with the credits and the actual grade value. So I have the 4.0 there. Then in the denominator, what we need to do, if we look on our formula, we have W sub 1 plus W sub 2. We have to add up all the weights. So the denominator is the sum of all the weights. All right, so again, I've taken the liberty of doing the busy work for you. You will get one of these to try. And we'll also talk about today one of our general rounding rules. We'll talk about one of our general rounding rules. And you guys will get one of these to try, and I encourage you, first of all, I'm hoping we're starting to see the need for our calculator in general. And I want to give you one to try so you can try putting those things in, because sometimes, even though the computation we need the calculator to do, the multiplying, adding, dividing, isn't difficult, sometimes we make mistakes entering it in, and then the order of operations is thrown off. So I want to make sure we get some practice with that. Now the question I always get is, so Miss Kelly, what do I round to? This one doesn't terminate, this one doesn't repeat. What do I round to? Our general rounding rule is to round to one more, sorry, it's a terrible E, one more place value than the original data. There we go. So our data values, that's our grade column again, those X's, our original data, they're all rounded to the nearest tenth. So if I need to round my mean, I'm going to go one more decimal place, so I'm going to go hundredths. That's our general rounding rule. So you don't have to keep asking Miss Golly, what do I round to? What do I round to? One more decimal place value than the original data itself is your general rule of thumb. Whenever you are ready, on the back of your sheet, I'll leave this up here as an example because I know it's not ideal to flip back and forth. On the back side of your sheet, there is one of these for you to try. And the first question I always get is, Miss Golly, how do I know what the weights are? And how do I know what just the values are? Whatever you're asked to find the weighted mean of, those are your data values. The other information is your weights. So we were asked to find the weighted mean for a GPA. So the grades were my regular values and the credits were my weights. So for this one, we want to find the weighted mean of the prices. So the prices are going to be our plain old data values. And then the quantity is going to be our weights. So I will leave this up here on my screen while you guys try that one. All right, I'm starting to hear a lot of calculator covers slide off, so I'm going to guess our setup is probably ready. So I'm going to go ahead, I'm just going to get my setup up here so you can check that out before you start doing your calculations and things. And again, we talked, you want to find the weighted mean of the prices. So the price, those are my X values. Whatever you're trying to find the weighted mean of, those are your X values, your plain old values. And then the other piece are going to be your weights. Get used to the notation, X bar. Get used to that for being our mean. And it doesn't matter if you put the actual value times the weight or the weight times the value. The formula shows weight times value. If you do value times weight, it doesn't matter because multiplication is commutative, which means we can flip-flop. So it doesn't matter. So if you did 2.5 times 10, and I'm putting 10 times 2.5, you're fine. Please don't go back and erase. Please do not go back and erase. Now, if you do get your weights and your plain old values, if you get those backwards, your numerator is still going to be okay. But it's all about what we're going to divide by in the denominator. Those are going to be our weights. That's where it's going to matter. And I do encourage you, if you do have that calculator handy, to try entering these things in. I know some of the graphing calculators, you can actually create a fraction right on your screen, and that's really awesome. You can enter everything you see on the top and everything you see on the bottom. If you don't have that feature and you want to enter everything in at once on your calculator, you need to make sure that you throw an extra set of parentheses around your numerator and your denominator. If your calculator won't just put the fraction actually on there for you, you have to make sure you tell the calculator you need to do everything on the top first, then everything on the bottom, and it needs to divide last. If you don't have those extra sets of parentheses, the calculator is going to do the division first before it does that addition piece. It's going to do order of operations. So make sure you have those extra parentheses. what we should come up with, that numerator piece, you should get 121. The denominator piece, we should come up with 35. If we go ahead and do the division, because 121 35ths, that's not super meaningful as a mean price. If I want a mean price, a fraction doesn't tell me much about the price of anything. So we would have $3.46 would be our weighted mean of the prices, is what we would have for that. Now, what I did today is I just went through this first section and I pulled out all the things that I know you have never heard of before, probably have never seen before. Now, what you need to do, and we do have quite a bit of time, that was intentional for me. For the assignment piece, first of all, make sure you read. I did not go through every single little thing from the section with you today. I went through and I pulled out the things that I know you probably have never heard of before. You've probably never had to calculate the things today that we went through. So make sure you read this section. Then for the assignment piece, what I've done is I've separated it out by topic. Notice, mean, median, mode. Didn't talk about those today, but I know those are things that, once upon a time, you guys have all calculated before. If you're like, oh, Miss Galley, I don't remember how, that's where that piece comes in. Okay? I hit the big things that you've never seen before. And then we have our mean and modal class for group data. That's the first thing we did today. The weighted mean is the last thing we did today. These two types, which type should be used? And the last two that I say to try for sure, again, that's going to link you back to, you're probably going to have to do some reading in the section to refresh yourself on those things. Okay? Now, if you're like, Miss Galley, I don't like that list thing, give me an assignment. What should I try to make sure that I've got this? So what I did is I did give you a suggested assignment. If you don't like that I've pulled it apart by topic, I've given you the suggestion. Here's the bare minimum of what I would do to make sure I'm solid on this section. And then you can go back and feel free to try any more of anything you need. Okay? I still do need to get the Chapter 3 answers posted on It's Learning. I will post those underneath today's date. And on the Resources tab, they'll also be in the Chapter 3 folder for you. Okay? They'll also be in the Chapter 3 folder for you. So I'm just going to double check. I don't remember if I posted those or not for you.